We'll discuss what actually is a mole, definition of mole, understand the key terms, then we'll convert the one mole into the other units and from the other units to the mole as usual. And for each and every concept, each and every conversion, we'll do example questions so that there is a concept clarity. And then at the end, we'll discuss some previous year questions. Coming to definition of mole. For what purpose we use mole? We use mole for calculating the amount of substance. The amount of substance that we calculate, generally we use kgs for anything, for weighing the vegetables, for weighing the grasses and so on, and liters for weighing the liquid items or the fluids. The same way, in chemistry, we use the term mole to weigh or to calculate the amount of the substance which we are taking. As we can't take the substances in kgs or grams because kgs and grams contains a very huge quantity, we take mole as the standard one. What is a mole? Mole is nothing but 1 by 12th of carbon atom. 1 by 12th of weight of carbon 12 isotope. 1 by 12th of weight of carbon 12 isotope. Why do we take this? Because we need some standards. For example, if you are taking meter, a scale which is there in the standard museum, a scale which is there is taken for the standard for a meter, using which we will be calculating the centimeters or millimeters. We will be taking one standard using which we do calculate the other measurements. The same way, the standard which we are taking here for mole is carbon 12 isotope. Okay, and for carbon 12 isotope, we are taking 1/12 of the weight of carbon 12 isotope, which is mole. So I hope it is clear for you. Mole is nothing but any substance, okay, any substance which contains same number of elementary particles. Elementary particles may be atoms, molecules, or ions which can't be further divided. So same number of elementary particles as the number of atoms or the elementary particles present in the 12 grams of carbon 12 isotope. This is how we define the mole. Then coming to the conversion of mole. What is actually a mole? It's standard temperature and pressure conditions. We will be having two conditions. One is standard temperature and pressure conditions, and the other is room temperature and pressure conditions. What is standard temperature and pressure condition? It's standard temperature and pressure condition that temperature is equal to 273 Kelvin. Temperature is nothing but the 273 Kelvin temperature or 0 degrees centigrade, and pressure is 1 atmospheric pressure. These are the standard temperature and pressure conditions. Whereas the room temperature and pressure conditions, as we already know, room temperature is nothing but 27 degrees centigrade. So we'll add this up to the standard temperature. Okay, we'll add this up to standard temperature, which makes it up to 300 Kelvin. 300 Kelvin or 27 degrees centigrade is the room temperature, and the pressure is nothing but the 1 atmospheric pressure. These are the two conditions which we use in chemistry or the stoichiometry. So now, at standard temperature and pressure conditions, what is a mole, or how much we can convert the mole into different quantities? At standard temperature and pressure conditions, 1 mole of any substance, okay, 1 mole of any substance at standard temperature and pressure conditions is equal to 22.4 liters of volume. For example, if I am taking 1 mole of oxygen, 1 mole of oxygen, 1 mole of oxygen will be equal to 22.4 liters of volume. 1 mole of oxygen, I can take 1 mole of oxygen will always occupy 22.4 liters of volume. The same way, 1 mole of any substance is equal to gram molecular weight of the substance. Okay. Or simply we can say, what is a gram molecular weight? Gram molecular weighting is nothing but the molecular weight of the substance which is taken in grams. The molecular weight of the substance, when we take it in grams, we call it as gram molecular weight of a substance. For example, if we take water, if I take water, we will calculate the molecular weight of the water. Atomic weight of hydrogen is 1, and there are 2 hydrogen molecules. When you multiply 2 into 1 and then you add the atomic weight of oxygen, which is 16. As we have only 1, we take only 1, which will become 2 plus 16, that is 18 units. What is the unit? Atomic mass units. Atomic mass units. This is the atomic weight of the water molecule, and we are taking this atomic weight of the water molecule or molecular weight in grams. That is why we call it as gram molecular weight of substance, which is 18 grams of water molecules, or 18 grams of water is equal to 1 mole. 18 grams of water is equal to 1 mole, or 1 mole of water will occupy any substance, will contain 22.4 liters of volume, or will be equal to the gram molecular weight of the substance, or will be equal to the Avogadro number, or will contain the Avogadro number of molecules. Clear? Then we will check a question so that we can understand the concept clearly. First, we have to find the number of moles which are present in 5.6 liters of carbon dioxide. How do we do this? For which we already have weight of carbon dioxide. We will take the weight carbon dioxide. 1 mole of carbon dioxide will occupy 22.4 liters of volume. Right? We already know 1 mole of any substance at STP. 1 mole of any substance at STP will occupy 22.4 liters of volume. Now, if it is occupying 22.4 liters of volume, what we need? We need to find the number of moles. X moles of CO2. Number of moles we don't know, we need to find out. So, X moles of CO2 will occupy 5.6 liters of volume. 5.6 liters of volume. So, for you to remember easily, what do we do for the calculation? Whatever is opposite to this X will undergo in the place of a denominator. Okay. So, here we get 22.4. In the denominator, we can write 22.4, and in the numerator, we have here 1 mole. So, 1 into 5.6. So, X moles of carbon dioxide, X will be equal to 1 into 22.4 by, 5.6 by 22.4, which we can write it as 56 by 224. Okay. Then we can do the calculation. 2 2s are 4, 1 5, 2 8s are 16, 1 1 2, again 1 4, 5s are 10, 6 12, 2 7s are 14, 8 1s and 4s, which is equal to 1 by 4, 0.25. 1 second. 0.25 moles. This is how you can convert volume given into moles. We can find out the moles using the volume which is given. Another, find the volume. Now here we are doing it reverse. Earlier we found number of moles from volume. Now here we are finding out the volume using the number of moles. So we have 6 moles of methane. So what is the formula of methane? Methane formula is CH4. Okay. So 1 mole of methane will occupy 22.4 liters of volume. Okay. Now 6 moles of methane. 6 moles of methane will occupy how much of volume? Or X liters of volume. So obviously, the one opposite to the X will be the denominator. Okay. So 6 into 22.4. 134.4 liters of volume. Okay. Now, we'll discuss another question. Now, here we will be calculating the number of moles which is occupied by 68 grams of ammonia. So, earlier we did a comparison from volume to moles. Now, here we are doing comparison from grams to number of moles. Okay. Now, we have to calculate the ammonia first, molecular weight of ammonia. So, ammonia molecular weight is 14 is the atomic weight of sodium, nitrogen, and 1 is the atomic weight of hydrogen. As there are 3, we are multiplying with 3. So, which will get 14 plus 3, 17 units or 17 AMU. 17 units is the atomic weight of ammonia molecule. Okay. Now, we will be discussing the molecular weight. How do we find the molecular weight? Now, we know 1 mole of any substance will occupy its gram molecular weight. Gram molecular weight, right? So, how do we calculate number of moles? Number of moles will be equal to weight of the substance which we got by gram molecular weight. This is what the formula that we use for finding out. Number of moles is equal to weight by gram molecular weight by substance. So, what will be the weight here? Weight which is given as 68 grams. N will be equal to 68 grams by gram molecular weight of the substance which is equal to 17, for which we get 4 moles. So, we have 4 moles occupying 68 grams as the answer. Clear? Now, here we will be converting moles to the weight. Same formula we use. Number of moles is equal to weight by gram molecular weight. Here molecular weight of hydrogen will be 2 as it is a diatomic molecule. So, number of moles is given as 8. Weight we need to find out. Gram molecular weight is 2. So, X will be equal to 88 into 2 which is equal to 16 grams. Simple. Now, find the number of moles using Avogadro number. We took the relation from volume to number of moles to volume, weight to number of moles to weight, and now we will be taking Avogadro number to number of moles and then number of moles to Avogadro number. Here we have to find the number of moles and we got the Avogadro number or the number of molecules present. So what will be the formula that we use? We know that 1 mole of any substance will occupy or will contain Avogadro number of molecules, 6.022 into 10 to the power of 23 molecules. You may get confused with this exponent, so be careful when you are looking at the question. This is where you need to read carefully. Okay. Now, number of moles we need to find, and the number of molecules given is 6.022 into 10 to the power of 24. Here, number of moles, N equal to number of atoms or molecules present by Avogadro number. Number of atoms or molecules present by Avogadro number. So which will be equal to 6.022 into 10 to the power of 24 by Avogadro number, which is 6.022 into 10 to the power of 23. We get cancelled up and we get 10 as the answer, as 24 minus 23 is 1. So 10 to the power of 1 will be 10 again. So we have 10 moles of carbon dioxide. Why do we write, when we have so many numbers, why do we write like this? Why our decimal is required when we have so many zeros over here? The reason is scientific notation. The reason is scientific notation. What is scientific notation? In order to write any number or to represent any number or for the easier calculations, we take a standard form of representing any values, where we take one digit followed by a decimal place with 10 to the power of any number, whatever is required. Okay, like if we are taking 25 kgs of anything, 25 kgs of anything, how do we convert it into grams? It will be 25 into 1000, which if we have to write it in scientific notation, we'll write 2.5, one decimal, 1, 2, 3 zeros and a decimal point. So 10 to the power of 4 grams. 25 kgs in scientific notations, if we have to write in grams, can be written like this. This is how we represent scientific notation. Next, this is a JEE question which we got in the previous years related to the concept. What we have to do in this, we have to find the number of atoms in the following samples, which is the largest. Okay, we got 127 grams of iodine, magnesium, chlorine and hydrogen. For this, what are the prerequisites that we need to learn? First thing, we have learned the mole concept. Second thing, we need to remember the atomic weights of the substances. What are the atomic weights of the substances? The atomic weight of iodine is 127 units. The atomic weight of iodine is 127 units. Magnesium is 24 units. And that of chlorine is 35.5 units, whereas hydrogen, as we already know, is 1 atomic mass unit. This is the atomic weights of the substances which will not be given in your examination. You need to learn them before you go to the exam. Along with the mole concept, what you need to remember to solve this question is the atomic weights of the substances. Right? Now, we will find the solution for this. How do we find the solution for this? We know number of moles is equal to weight by gram molecular weight. So, which is equal to 27 grams of iodine. 27 grams of iodine. We have 127 grams of iodine. So, 127 grams by gram molecular weight 127, which is 1 mole. Okay, then why I am calculating moles? Because so that I can convert it into atoms later on. Now, number of moles for magnesium, weight by gram molecular weight, which is equal to 48 by 24, that is 2 moles. Then coming to the chlorine, weight by gram molecular weight, which is equal to 71 by 35.5, which is equal to 2 moles again. Then for hydrogen, it is 4 by 1, which is equal to 4 moles. So we can using the number of moles, 1 mole contains same number of atoms. Whatever may be the atom or molecule, one mole contains same number of atoms. So more the number of moles, more will be the number of atoms. So by looking at this, we can directly conclude that 4 moles, that is hydrogen, contains more number of atoms in this sample, among this sample. Okay. This is how you need to solve the JEE questions within a short span of time. The more faster you practice, the more faster you can calculate during the examination. If you have any doubts related to the